they solve difficult questions into easy questions. Like, how do you guess? Guessing is also part of GMAT because, as 700 scorers, we might think, you know what, we shouldn't be guessing in our test. But there would be circumstances where you would have to. And to save time, you would have to. So it's important that from the very first class, from the very first, I show you how to guess in GMAT, right? So first kind of guessing technique which I have. So let me go back to my whiteboard, and okay, so I think I've filled up my whiteboard. I'm going to start another one. So going back to my whiteboard, I'm saying go hybrid. And when you go hybrid, the answer options are variables, and the question is asking you which of the following. So here it's like aggressive elimination. Like in plugging in, you hope that you don't get more than one answer option giving you the same answer, but here you will. So this is like aggressive elimination. Now the next technique that I have is guessing, advanced guessing. First advanced guessing is if the question is asking you anything, let's say it's asking you what is the sum of these numbers, or it's asking you what is this numbers. So rather than finding the exact number, what you can do is you can find the range. And if you're lucky, the answer option, only one of the answer options is within the range, then you're lucky. Let's see this question here. So this question says, let S be the sum of reciprocals of consecutive integers from 21 to 30. So what is S? S is 1 over 21 plus 1 over 22 all the way till 1 over 30. So it's difficult, right? It's a harmonic progression, and I don't expect GMAT students to know what harmonic progression is, and even they don't expect that. What they're expecting is you to find the range. So what is the S minimum? S minimum would be if all the numbers are 1 over 30.
Yeah.
So 1 by 30 into 10, right? Because there are 10 numbers. So that's 1 over 3.
I think the OG also has a similar question where it's like 1 over, I think it's 200 to 300.
Okay. So yeah, pretty much the same thing. So S minimum is 1 over 3. What is S maximum? That would be, let's call it 1 by 20.
1.
I'm not going to do 21. I want to say, let's say 1 by 20. So into 10. That's half. So that means my number lies between half and 0.33. Isn't it? That's like the range of my numbers. So this is no, this is no, this is okay, this is no, this is no. That's the answer.
Okay.
Yeah. So
you have to hope that one of the answer choices actually is in the range.
Yeah. So even if there are two, you can still guess over there. You can do another type of guessing there. But this is like the basic idea of it. Find the range of the answers. And I've chosen like the perfect question for it. And you might not have the perfect question for it. But still, if you're stuck, this is the way to move forward in these kind of questions.
Okay.
Okay. So basically what I'm showing you in these problem solving techniques so algebra, when you use algebra, you try to prove something. But here what I'm showing you is how to disprove, how to eliminate. So it's all about process of elimination. Whenever you can eliminate an answer option, eliminate that. One of the very subtle and very small type of technique is it's positive negative. So if you know the answer is positive, you can eliminate the negative answer options. Let's see this question. It says it's an easy question. A by B is 3 by 4. What is A minus B? And I think you should be using algebra in here, but just to show you there. So what is A minus B over B? So you know that A is less than B. If A is less than B, that means this thing is negative. If this thing is negative, you can just eliminate these. So this will not let you within these two questions. But what if this is the 37th question and you have 10 seconds? Or let's say you have 5 seconds, right? So you look at it, or 5 seconds are way too less. Let's say 15 seconds. This is negative. You can eliminate these three and you are at least down to 2 answer options, and there's a 50% chance of you getting the right answer, then 20%. I hope that's fine. I think I don't have a good question for this strategy, but did you get what I'm saying?
Yeah. No, I understand.
Okay. Now the next type of technique is to ballpark. Well, when we're trying to find the range, we're ballparking. But especially in geometry questions, the if the GMAT question is telling you the figure is not to scale, all the figures are to scale. So you can use that to your advantage. Right?
Okay.
You can ballpark, but there is a way to ballpark. I'll show you the. So I have a video, full-fledged video on ballpark, but I'll show you how to do that here. So let's say you have this question. The question is saying ABCD is a square. So like this thing is a square, this thing is an equilateral triangle, and this thing is a circle. It says what fraction of area is covered by the area of the circle. So what fraction of the area of the square is covered by the circle? So first thing is you want a ballpark. This question is way too much. And some questions can only be solved using ballparking because they are way too difficult to use the algebra in there. So you have this. First, tell me what fraction of the square according to you. First, cut the square into halves. So I'm cutting the square into halves. So this is cutting the square into half. There you go. So what fraction of the whole square is this ball? Give me a number. And always start with numbers like, is it 75%? Is it 50%? Is it 25%? Don't say like 21.2%. Just ballpark in these regions, or 10%.
25.
25, yeah. So that means here the answer should be 1 by 4, isn't it?
Yes.
Pi is 3 plus. 3 plus by 2. That's not 1 by 4. Gone. This is 3 plus by 4. That's not 1 by 2. 1 by 4. Gone. That's not 1 by 4. Gone. That's not 1 by 4. Gone.
Sorry, what do you mean by that? Pi is
3.14, right?
Oh, okay.
So I'm calling it
so
3 plus.
3 by 2, 3 by 4, 3 by 6.
6, 3 by 8, 3 by 12. So this is like 50%. This is like 75%. This is this is 150%. This is 50%. This is 3 by 8, which is 37.5%, and this is 25%. If this ball would have been a little bigger, I would have been within these two answer options. But I know this is 25%, so E is my answer.
How would this question be done if not this way?
If you want to do it algebraically, okay. So the question is that you have a square, you have a equilateral triangle, you have a circle. The question is asking me fraction, so I can choose to plug in, right? I can say, let's say this is 10 and this is 10. So the area of this thing is 100. So what is the area? And this is 10 too, right? The side of the equilateral triangle. So what is the area of an equilateral triangle? That's square root 3 by 4 side square.
I need to start remembering these.
I have video on that. You can when we go to the geometry week, you will know all that. Whatever I'm putting there on the slide, I have all of that in the videos. So don't no worries there. So square root 3 over 4 into 100, that's 25 square root 3. So that's the area of the equilateral triangle. What is this?
Yeah.
This is, damn, I forgot. That's R over square root 3. I need to double check that, but okay. So this is R over square root 3. When you have an equilateral triangle,
how do you get
this
that?
is side over square root 3. Okay, so let's say if you have an equilateral triangle, so this is again I've explained in the video about equilateral triangles. You have this as the circle. So this is the circumradius. This is the circumradius, and sorry, this is the in radius. This is the circumradius. So this is also the circumradius. Sorry, yeah, circumradius. This is the height of the equilateral triangle, right?
Yeah.
Height of the equilateral triangle is given by square root 3 by 2 side. So, and this point gets cut at 2:1. This point cuts the whole height at 2:1 because this is the point of median. Like this is the point where all the medians meet in an equilateral triangle. So this cuts is at 2:1. So you following what I'm saying?
Yeah.
I'll just explain it again. This is an equilateral triangle. This is the circle. This is the circumradius. This is the in radius. This is the point where all the medians meet, which cuts the height or the median in 2:1 in an equilateral triangle.
Got it.
So if this cuts it in 2:1, what is this in part? That's 1/3 of the height. So that is, yeah, that is s over 2 square root 3. And that is the in radius. The circumradius is s over square root 3.
Okay.
Yeah.
Yeah, because it's 2:1.
Yeah. So yeah, so this is s. So this is s over 2 square root 3. I was wrong there. So s over 2 square root 3. It's been a while where I've used these formulas. S over 2 square root 3. So that means s over 2 square root 3, which is 10 over 2 square root 3, which is 5 over square root 3. So 5 over square root 3 is the radius of the circle. What is the area? Pi r square. So pi into 25/3. What fraction of this is this? Pi over 25/3 over 100. That gives you pi by 12.
Okay, got it.
And that's what we got here.
Yeah.
Pi by 12. So just a second. Yeah, so that's ballparking, and I'm gonna assign you the video to watch on that as well. So am I clear with that, right? This is fine, right?
Yeah.
Okay, perfect. Let's see this question. So help me out here. This is like an easy question, but still you can solve it using ballparking. The question is asking you what is the sum of the arc lengths AB, BC, and CA. So the question is asking you this plus this plus this. Right?
Yes. With radius 3 centimeters.
Yeah. So instead of finding this, this, and this, can I find this, this, and this? That's approximately the same thing.
Yeah, but wouldn't all these...
I mean, instead of finding the curves, I can find the straight line from AB, straight line from BC, straight line from AC.
Okay.
And what is each line? That's 3 centimeters. So it's 3 plus 3 plus 3. My answer should be close. My answer should be greater than 9, right?
Yes.
So that's like 3 plus. That's not greater than 9. That's 6 plus. That's like 6 point something, not greater than 9. This is 3 into 2 plus. Same thing, not greater than 9. This is 3 into 3 plus. Okay, that could be my answer. And this is 4 into 4 plus. That's way bigger. That's D is the answer.
Okay.
There was a time when I used to solve every question using ballparking. I don't know why, but you should not use it every time. Only use it when you're stuck.
Okay.
Yeah, this is just when you're stuck. I will not recommend this when you can solve it using algebra under 2 minutes. Fine? You got that? Okay. Yeah, so this was about the problem solving strategies that I had. And do you want to discuss the questions you got wrong?
Yeah, I mean, what do you think? Do you think I should go over them once and see?
You should see whenever you write your test, just make sure that you go through the questions that you got wrong, because that's data about you, personalized to you, and you should know where you got wrong so you don't repeat the same mistakes again. That's like the thing. So if you want me to go over them, I can go over them. If you want to go over them yourself and then let me know which ones you didn't understand, and then that's up to you. That's completely up to you. If you haven't gone through them, I would recommend you to go through them yourself and then try to identify the mistakes that you made.
Yeah, I can do that.
Yeah, but I can go through this question. See, this looks like a which of the following question, right? So R is between 0 and 1, S is between 1 and 2. Which of the following must be less than 1? So I can say R is, I can say that R is half.
Yes.
And I can say S is 1.5, right?
Yeah.
So which of the following must be less than 1? Let's see this one. So that's half over 1.5. That's 1 by 3. That's less than 1. R into S. Half into 0.5. So 1.5 into half. That's 0.75. Now think if I can make this greater than 1. That would be,
well, if you take R as
0.9
like 0.99
and this as 1.99, that's almost, that's almost like 2. So that's gone. Sorry, that's almost 2, so that is gone. What is S minus R? Even if you choose the same numbers, 1.99 minus 0.9, that gives you 1.01. That's still gone. So think about R over S. R over S will always be less than 1. Now here you can use a little bit of algebra to kind of prove this, because now you're only left with one answer. So R over S, this is something which is between 1 and 2. This 0 and 1, this is something between 1 and 2. There's no way R could be equal to S. All the time R would be less than S. So if R is going to be less than S and they're positive, R will always be less than 1. So that's the mathematical proof of that. So A is the only one satisfies.
Okay.
Let me see if there's a question which could be solved. I think this, if n denotes a number left of 0 on the number line, such that square of n, so square of n is less than 1 over 100. And n is a negative number though.
Yes.
Then the reciprocal of n must be. So if, see, the algebra, if you want to do the algebra here, you can always say if n squared is less than 100, n is either less than 1 over 10 or it is greater than minus 1 over 10.
Yes.
So we're going to take only this part. Or no. 1 over 100, minus 1 over 100, minus 1 over 1. Okay, so now let's do the reciprocal. If we do the reciprocal, it's going to be 1 over n, and this is going to be minus 10. And this sign will flip when we, because if there's a negative number involved, when you reciprocate or when you multiply by a negative number, the sign flips. I think you got that.
That's what I was having an issue with.
Okay, so it's called the flip rule. The flip rule is that whenever you have an inequality and you multiply by a negative number, you divide by a negative number, or you reciprocate and there's a negative number involved, you will flip the signs. Like 3 is greater than 2, but minus 3 is less than minus 2. The sign flips. Yeah.
Because I kept thinking I'm only dividing by 1 on both sides.
No, you are reciprocating it. So you kind of are dealing with negative numbers here. So what you're doing is, let's take that example. Let's say 3 is greater than minus 1 by 2. Let's reciprocate. 1 over 3 and... Oh, but you have negative numbers on both sides. Okay, so you have negative 3 is less than minus 1 by 2. You reciprocate, that becomes negative 1 by 3, and that becomes minus 2. So that's greater.
Does this hold for, so here you have negative on both sides. Does this hold for when you have negative and positive?
take an example. So I think it will not hold for, because if you reciprocate a positive number, it will stay positive, and a negative number, if you reciprocate it, it will stay negative. So it only works when you have the same sign on both sides, when you reciprocate.
So in this case, it's minus 1 by 10 is less than n. So
N is a negative number too.
consider-
N is a negative number too.
Oh, okay.
Yeah. Whenever in doubt, take an example. That's how I work too. Whenever you're in doubt, just take an example.
So the flip rule essentially works with negatives on both sides.
Yeah, and positives on both sides.
Yes.
If you reciprocate, you gotta have the same
Yeah.
sign. Yeah. Yeah.
Okay.
Let's say if you have a question like that. For every integer k from 1 to 10, the kth term is given by this. If t is the sum of first 10 sequence, then t is. So what is t? It's minus 1 raised to the power 1 plus 1, which is positive, 1 over 2, minus 1 over 2 square, plus 1 over 2 to the power 3. And it will go on to the last one, which is minus 1 over 2 to the power 10.
Yeah.
Now you can solve it. You can solve it two ways. I think you can solve it using logic, or you can solve it using geometric progression. So in geometric progression, the first term is 1 by 2. The multiplication term is minus 1 by 2. Each term is getting multiplied by minus 1 by 2. So sum till 10 terms is going to be equal to a into r to the power n minus 1 over r minus 1. That will give you like the exact sum. I have a video on geometric progressions too. So this is the sum of geometric progressions for a finite sequence. If you want to use logic, and I would recommend logic in that, what you can do is take all the, okay, first of all, this is 1 by 2. The next term, let's focus on this term. What is this term? Is this positive or is this negative?
1 by 2 cube minus 1 by 2.
So that's negative, right? Because you have a bigger number negative plus a smaller number positive.
Yeah, because 1 by 8 minus 1 by 4.
Yeah, so that's negative. That's negative 1 by 4. Isn't it? Or what is this? This is, okay, this is negative.
Yes.
The next pair is going to be negative. That's 4 and 5. The next pair is going to be negative. That's 5 and 6. The next pair is going to be negative. That's 7 and 8. The next, no. 2 and 3, 4 and 5, 6 and 7, 8 and 9. And even 10th itself is negative.
Yeah.
So that means your answer is definitely less than 1 by 2. Isn't it? Because you have 1 by 2 and a bunch of negative terms.
Okay, so the question is now between D and E.
Yeah, it's between D and E. Now, look at what is between D and E. Can it be less than 1 by 4? So that's what you have to see. Now, if you want to see whether can it be less than 1 by 4, what you can do is, I'm thinking here, there are 1 by 4, 1 by 4, 1 by 4, 1 by 4. That's 1 by 2. What is this thing? 1 by 8 minus 1 by 4. What is 1 by 8 minus 1 by 4? That's 1 by 4?
30. Yeah.
So that's negative 1 by 4, right? And what's 1 by 2 minus 1 by 4? What is this first two terms? That's 1 by 4, right?
Yes.
Yeah, perfect. So we have the first term is 1 by 4. And then after that, what we had? We had plus 1 by 2 cube minus 1 by 2 raised to the power 4. So we have plus 1 by 2 cube, minus 1 by 2 to the power 4, plus 1 by 2 to the power 5, minus 1 by 2 to the power 6, and so on till minus 1 by 2 to the power 10. Okay, this is 1 by 4. Let's see, what is this? Positive or negative? Positive, right?
Negative.
No, it's positive. 1 by 8 minus 1 by 16, that's positive.
Okay, because it's bigger number minus smaller number.
Yeah. This is positive, this is positive, every consecutive term is positive. So you have 1 by 4 plus something, so it's greater than 1 by 4.
Okay.
So that means this is gone and this is the answer.
I
Right?
think I should go over these questions myself first.
Yeah, but like you have two ways of solving it. You can straight away use the geometric progression formula, which I would recommend. But if you sometimes you have questions where it doesn't work, so you can always use the logic. You can always use things like these, and and that is like an art, not a science. So basically, I'm saying use either science or use art. So there's that. Is that fine?
Yes.
Okay, perfect. So let me do one thing now. Let me send you an email by today, and that email will contain the questions that you have to solve, the videos that you have to watch by next week. I will make sure that I give you enough content so you can spend 2 hours every day. For sure, I'll do that. And so I will send you an email giving that. I will put the recording as well. I will just render it now. I'll put the recording on your course as well. And do you have any question for me?
I'll send you some options for the next class. So I mean, you're going to give me stuff for about 7-8 days. Is that good? Don't think I'll be in class this time next week. That's why.
Let's take the next class till you have made some progress in the problem solving once. And
okay.
So what I can do is I can discuss your problem solving doubts, and I can take forward data sufficiency, so that you can decide when you think you have enough progress in that.
Okay, that sounds good. So
Yeah.
I look forward to your email, and I'll and again I think yes, weekly, just like what I need to do in a day. I work better with just this is what I need to do today. I'll do it. But when it's like all of it, I'm really lost as to how much to do.
Just do whatever I ask you to do, and I think rely, just throw all that planning on me. I'll send you that, and I will also send you like the verbal videos to watch and the questions to solve, so that you're solving verbal as well along with that, right?
Okay,
I'll get you in touch with the verbal instructor, and she'll send you. You already at 35, so she'll send you some difficult questions and this there. So, and videos to watch. In verbal, there's nothing beyond like few videos, and then you have practice. Just practice.
Yeah, and I've been with verbal. I've really been just going through OGs and doing sets of 20-25 questions.
Yeah.
Okay.
Yeah. Okay.
Okay. Okay, thank you so much.
No problem. Thank you very much for coming to the class, and see you next time.
Okay, we'll be in touch.
Yeah, I'll end the event. Thank you.